Everybody. We're going to continue on our discussion of chemical equations today. I want to start off by talking about the diatomic elements. The diatomic elements are 7 elements that occur in nature as molecules of 2 of them bound together. Those 7 elements are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. I like to think of the name Brinkelhoff that this arrangement suggests, but not everybody can remember Brinkelhoff. There are a couple of mnemonics to remember. The first of them is have no fear of ice cold beer. Now, of course, some people say that's not high school appropriate. As long as you're not actually drinking beer, if it helps you remember the 7 diatomic elements, go ahead and remember that phrase. Have no fear of ice cold beer. H is hydrogen. No is for nitrogen. F is fluorine. O is oxygen. I is iodine. Cold, Cl, is chlorine. Beer, Br, is bromine. Okay. Also, on the periodic table, these are often referred to as the magic 7, and the reason is they form a 7 on the periodic table. And you can see here's hydrogen by itself, and then here is the 7 that is suggested by the other elements. Of course, acetine shouldn't be in there, but maybe it is diatomic, and I'm just not aware of that. All right. So diatomic elements are important, and the reason they're important is when we go to balance an equation, we have to know which of our elements are diatomic. If an equation calls for oxygen, we have to remember that oxygen occurs as a pair. Iodine occurs as a pair, nitrogen as a pair, and that's going to make a big difference when we go to balance our equation. So let's talk about the different ways in which we get to the balanced equation. Sometimes in a problem statement, you might see a sentence describing a chemical reaction that occurred. The sentence might say something like, solid iron reacted with chlorine gas to form solid iron 3 chloride. Well, that can be put into what's called a word equation. The word equation includes the names of the chemicals rather than the chemical formulas. Here we have solid iron, here we have chlorine gas, and here we have iron 3 chloride, and I made a boo-boo and forgot to put the solid on there. So I'll do that now. There we go. Okay. Now, a word equation is fine, but doesn't help us, and we have to have that balanced equation. So what we can do is we can step this to what's called the skeleton equation. The skeleton equation includes formulas. You can see chemical formulas here, but they are not yet balanced. Okay, the equation is not yet balanced. This is where there is room for some error. For example, iron, Fe by itself, it's an element, it's a metal. It is not a diatomic, so its symbol is just Fe. Chlorine, on the other hand, is one of our diatomic elements. So we would put Cl2 as its formula. All right, and as we studied in our last chapter, iron 3 chloride is an iron with a 3+ charge, and it's going to be attached to 3 chloride ions, forming this FeCl3 with no charge. If you're having trouble with this, it would make sense to go back and review ionic compound naming. All right, so here is our skeleton equation. Iron plus chlorine form iron 3 chloride. Perfect. But in order to use that, we need to balance it. And to balance it, we have to have all the atoms on this side of the equation be the same as all the atoms on this side of the equation. The atoms in have to equal the atoms out. Now, the only thing that we get to do is change these coefficients. We do not get to change any chemical formulas. Okay, so let's get into balancing equations. First of all, this is an essential skill in chemistry. This is one of those things that if you leave this class not knowing how to do this, you are deficient in your chemistry skills. It's not difficult to do. Once you get the hang of it, it does take a little practice. But you can't move forward without the skill. Okay, you need this no matter where you're going, and no matter what science you may study, you will need this skill of balancing equations. Okay, now why are equations balanced? They're balanced because the law of conservation of matter tells us that matter is neither created nor destroyed in all chemical processes. Notice that I do say chemical processes, because we've already learned that in nuclear processes, we can have actual change from matter to energy or energy to matter. But these are chemical processes, not nuclear processes. Okay, so every atom present as a reactant must also be present as a product. And if we're going to go any further in chemistry, you have to be able to balance the equation. Okay, let's look at how to do that. All right, so I've got some instructions here. Now, obviously, you can't just read the instructions and know the skill. I'm going to read through them, and then I'm going to work through an example with you, and hopefully that'll give you an idea. The only way to get good at this is to practice, 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 and for that reason, I will include a worksheet in your assignment. Okay. So, how to balance chemical equations. First, we're going to begin with the skeleton equation. Okay, remember the skeleton equation has all the correct chemical formulas. It just doesn't include the same number of atoms on each side. If you do not have the correct chemical formulas to start with, you will never get the correct balanced equation. Okay, then you take inventory. Okay, when we take inventory, we count the number of each type of atom or each element on both sides of the arrow. Okay, once we see that, we see where we are out of balance. Then we change coefficients. We only change coefficients. We never get to change chemical formulas. Okay, that changes the whole thing. Then we're talking about a different chemical reaction. So we get to change the coefficients only, and we adjust the totals each time until we end up with a balanced equation. Now, sometimes we overshoot the goal. Sometimes our coefficients end up all divisible by a particular number. For example, 2, 4, and 6. If our coefficients are 2, 4, and 6, those numbers are all divisible by 2. So, if that's true, I must do so. If I divide all these numbers by 2, I get 1, 2, and 3. And those will be our coefficients. Now, remember that 1 is not something that we actually write. We leave the space before the chemical formula blank, and that implies a 1. All right, let me go through the process of balancing this equation. So I've got here a skeleton equation, and that is what I said I needed to start with. I've got hydrogen, nitrogen, and ammonia. Okay, this is our Haber process from before, but it's a good simple equation to start with. All right, the next thing it says to do is take inventory. So we're going to go ahead and do that. Okay. The elements I have are hydrogen and nitrogen. Now, I prefer to write those element symbols underneath the arrow. Okay, now the reason I want to do that is because it just shows me visually the divide between my reactants and my products. Some people like to make two separate columns. That is totally up to you. This is just my method. Okay, so I'm going to take inventory. I have hydrogen, I have nitrogen. On my left side of the equation, I have 2 hydrogens right here. On my right side of the equation, I have only 1 hydrogen. On my left side of the equation, I have 2 nitrogens. And on my right side of the equation, I have 3 hydrogens. Okay. So, obviously, we are not in balance. 2 does not equal 1. 2 does not equal 3. Okay, we get to start moving, or changing, rather, coefficients. So, one of the things I see here is I see that I need... Oops, I'm so silly. I did the absolute opposite. I had 2 hydrogens. Let me fix that. I have 3 hydrogens, but only 1 nitrogen. I had them in reverse. Okay. Now what we're going to do is I'm going to take a look at this nitrogen. To me, that's a good starting place. If I put a 2 coefficient in front of this, that 2 is going to double the number of nitrogens and also double the number of hydrogens present. Okay, so that's going to give me 2 nitrogens, and it's also going to give me 6 hydrogens. All right, my nitrogens are in balance, but my hydrogens are still off. However, I take a look at this. Now I've got 6 hydrogens on my right side. So I can change my coefficient on my left side and end up getting 6 hydrogens. So if I put a 3 here, 3 times 2 is 6. All right, and so you can see 6 and 6, these are in balance. 2 and 2, these are in balance. Everybody's in balance, and my coefficients become 3, 1, and 2 for this equation. All right, that was a very simple example because it's a simple equation. There are a lot more complex ones. And again, the best you can do is practice, practice, practice. So I'm going to first give you some videos that show people working endless practice problems. And after watching some of those, you should be able to handle that on your own. Definitely use a pencil with an eraser, or if you have a whiteboard or something you can use as a whiteboard and a whiteboard pen, that's really helpful as well. Your mom probably wouldn't like it, but if you had a whiteboard pen and you wrote on, say, one of your windows, that would work. Just make sure you clean it really, really well so mom doesn't get mad. All right, guys, thank you for listening, and I will see you again on Zoom.